Welcome back everyone, Patrick here, moving on to another factoring question. So we are given three squares over here. We're told the largest square, which is this one on the left, has a side length of 3x plus 4, and then we're told that each consecutive square has a side length that is 3 less than the previous one. And two questions. Part A, we got to find an expanded expression for the sum of the areas of the three squares. And then in part B, we have to factor the expression from part A. So we're told the largest square has a side length of 3x plus 4, meaning that this is 3x plus 4, and then this is 3x plus 4, like that. But then we're told that each square after that has a side length that is 3 less than the previous one. So what would be the side length of this one over here? Well, we would take the side length of the previous one, 3x plus 4, and then just subtract 3. And when we do that, notice the 4 minus 3, those are like terms, and it would be 3x plus 1. So that means that this square over here has a side length of 3x plus 1. And then what would this square have a side length of? We would take 3x plus 1, the side length of this one, subtract 3, and we'd end up with 3x minus 2, right? 1 minus 3 is 3x minus 2. So that's the first thing to know, get the side lengths of all the squares. And then what we could do is we can go into the questions. So in part A, we have to find an expanded expression for the sum of the area. So we've got to get this area, this area, this area, and then just add it together. And then in part B, we have to take that expression from part A and then factor it. So let me actually erase this part over here. I want to keep the diagram for now. So let's start with the sum of the areas. What's the general expression going to be? Well, what's the area of this square going to be? Well, it's going to be just these side lengths multiplied by each other. So it's going to be 3x plus 4 times 3x plus 4. A more general way to write that would be 3x plus 4 squared, right? The area of any square that has a side length s is equal to s squared. So if s is 3x plus 4, and then we're taking 3x plus 4 and squaring it. And then we would add the area of this square, 3x plus 1, that's going to be squared, and then we'll add the area of this square, 3x minus 2, and then that's going to be squared, like that. So from here, what we would do is we would just have to expand all of this now. So I'm going to erase the diagram to get some room for the algebra. So what would we do here? Let me actually continue this here because I feel like we may need some more room. Let's first write out these expressions with two brackets. So we got 3x plus 4 times 3x plus 4, 3x plus 1 times 3x plus 1, plus 3x minus 2 times 3x minus 2, like that. And so what we could do is just now expand all of these. So starting with this one, we got 9x squared plus 12x plus 12x plus 16. Right, 4 times 4 is 16. Moving on to here, 3x times 3x, 9x squared, 3x, 3x, and then 1. And then over here, 3x times 3x, 9x squared, 3x times negative 2, negative 6x, negative 6x, plus 4, like that. And then from here, we just have to simplify all of the like terms. So I'm actually going to simplify first the like terms in the middle of each of these. So we'll have 9x squared plus 24x plus 16 plus 9x squared plus 6x plus 1. And then over here, 9x squared minus 12x plus 4. Just in case you maybe took these expressions here, notice that they are squared binomials. And we did a section before where we had a certain formula we were using. So if you do use that formula instead of doing this sort of manual expansion, these are the expressions that you should end up with. So I just wanted to write those first. And then from here, let's collect the like terms. So 9x squared, 9x squared, 9x squared. That's going to give us 27x squared, so those go away. Then we'll have 24x plus 6x, which is 30x, minus 12x would give us 18x. Those go away. And then we got 16, 17, 21. Like that, right? And then these go away. So this here ends up being the simplified, expanded version for the sum of the areas of the squares. So that's part A. And then in part B, what we got to do is we got to factor this expression. So let's start off with the numbers 27, 18, 21. The largest common factor between those would be 3. I was thinking it might be 9, but 9 doesn't go into 21, unfortunately. So it would be, let me just make sure. Yeah, it would be 3. So we could take out a 3. Unfortunately, we can't take out an x because not all of these contain an x. This 21 doesn't have an x. So if we take out a 3, what would we be left with? Well, we would just divide these by 3. So we'd have 9x squared plus 6x plus 7, like that. And then just a quick double check. Notice you can't take anything out of this bracket. 9, 6, and 7, those don't have a common factor. All right, so this ends up being the expanded expression for part A. That ends up being the factored expression for part B.